it says graph the line 4x plus 2y equals 8.
Okay. I just got it. Let's go ahead and take care of this one, though. 4x plus 2y equals 8?
Correct.
What's the general format for the equation of a line that I want to graph?
Well, give me a second. Isn't it,
I want you to know this by memory, not by looking it up.
let's do y equals mx plus b.
Okay. If you ever memorize anything, memorize that.
Okay.
So we need to put this equation into that format. So what do I need to do first of all?
So don't you need to get rid of the 8?
No.
No, you gotta get rid of the isn't it the 2y?
Okay, hold on a second. That's what I'm trying to solve for. I got to get rid of everything that is on that
Y side. Okay.
In other words, I want to end up at the end with y equals. So what do I have to get rid of?
You want to get rid of the 4x.
First of all, get rid of the 4x. So what's the right side now?
So it's going to be 2y equals 4x.
No.
No, negative 4x.
Okay.
Plus 8.
Okay. Now what?
And then aren't you going to
get rid of the 2? In other words, solving equations is really rather simple. You just have to get rid of everything that is attached to what you're trying to solve for.
So subtract 2.
I'm trying to solve for y. So I got to get rid of the 4x first, and then I got to get rid of the 2.
Okay. So then aren't you going to add 4x?
I already subtracted 4x. That's how I got rid of it. Now how do I get rid of the 2?
So don't you subtract it?
No. What is it currently?
Oh, divide. You divide all 3.
You always do the opposite of what it is doing. If it's being added, you subtract. If it's being subtracted, you add. If it's a multiplier, you divide. And if it's a divisor, you multiply. It's as simple as that. Okay?
Sounds good.
So what is y equal to?
Y is equal...
divide both sides by 2.
2. So isn't it just, so if I'm dividing each side by 2, isn't it just 2?
Okay, I'm dividing that side by 2, I'm dividing that by 2, I'm dividing that by 2.
So isn't it 1? No, it's 2.
What is that?
Isn't it, so negative 4x over 2, isn't that 2 over 1?
Yes. So what is minus 4x over 2?
2 over, isn't it just 1?
It's minus 2.
Okay, minus 2.
Here's what we were doing. Minus 4 divided by 2. That's a minus 2.
So for the 2y over 2, do those just cancel out?
Yeah, that's why we divide by 2.
Okay,
that will always cancel out. As long as you're doing the opposite of what that thing you're trying to get rid of is doing, it will always go away. Now what's the rest of this? We haven't finished it.
It's going to be 4 over 2, which is going to lead to 2 over 1.
Hold on. Negative 4 over 2 leads to minus 2.
Yes, and then...
What's 8 over 2 lead to?
4.
That's your answer.
Okay, that's making more sense.
And it is in that format. In other words, if we want to graph that, where do I start?
So you're going to start, okay, let me put that down. We're going to start at negative 2x.
No, you're going to start at the y-intercept. That is the y-intercept.
Okay, y-intercept. Okay, that makes sense. Okay.
So
y-intercept's
the y-intercept at 4. Now how do I apply the slope? This is the slope.
So it's going to be negative 2 over 1.
How do I apply it?
So aren't you going to go down 2 over 1?
Over which way? Because I can go over left, I can go over right.
To the right.
Okay. So I go down 2.
Over 1.
Right 1. And that does indeed produce a negative slope. That's the key, is that you recognize a negative slope when you see it. In other words, if I would have gone down 2 and left 1, I'd have had a positive slope.
Positive slope, yeah.
So you always have to make sure that what your slope is agrees with what you graph. And then it doesn't matter whether you say down or over. It'll come out as long as you get the sign right. Just remember, slope is rise over run. So you have to go up or down first. And then you go to the right, depending on whether you have a positive slope or a negative slope.
Okay.
Okay. All right. Let's have a look at my email here and see if your email got to me. Yeah. Second, let me download it.
If not, I might be able to verbalize it to you.
Okay, give me 2 seconds here. It usually takes a little bit of time to come up. Yeah, there, it's coming up now. Okay.
So, yeah, that's one of my big questions.
Okay. Hold on. Let's get it up here. Okay. So what they're saying is that angle 1, is equal to 5x plus 5y.
Correct.
Okay. So what other angle that they've labeled on here is equal to angle 1?
Isn't it 55?
No.
No, it's 60.
It's 60. 60 is no, excuse me. It's not 60. Here's the thing with parallel lines and a transversal. Okay? There's your parallel lines and a transversal. You with me? On upper left?
Yeah.
You create 8 angles. But you really only create 2 unique angles. Every angle that is acute is equal to every other acute angle on there. Every angle that's obtuse is equal to every other obtuse angle on there. So what's y equal to?
Isn't y equal to
1? What is angle 1 equal to on my picture?
Isn't angle 1's equal to angle 5?
Okay, they're both obtuse. That's correct. What else?
Isn't it angle 8 and 2?
8 and 4, not 8 and 2.
Oh, 8. Okay, yeah.
Notice that angle 2 is acute. Angle 1 is obtuse. Do you know the difference between obtuse and acute?
Yes.
One's less than 90, one's greater than 90.
Yes.
Make sure you recognize that. That is an obtuse angle. Therefore, it cannot be equal to an acute angle. It's equal to every other obtuse angle. Well, that's obtuse, and that's obtuse. So 1, 4, 5, and 8 are all equal. And 2, 3, 6, and 7 are all equal. You with me?
I am.
Now, when you have an acute angle and an obtuse angle, what do they add together? There you go. There's an acute angle and an obtuse angle. What do they add to?
Don't they add up to 180?
Always. That's the magic number in geometry. Okay. In this picture, is that obtuse or acute?
In the picture, that's acute. The two are acute.
No, it isn't.
Wait, hold on.
An angle like that. That's obtuse.
Oh, okay. I was sorry. I was looking at the top left. Oh
Okay.
yeah. Oh yeah. The
Now,
circle. Yeah.
is that
That's up.
acute or obtuse?
That is obtuse because it's less than 90.
That's acute.
Oh, that's what I meant. Sorry. Yeah. Acute.
Okay. So we have an acute angle and we have an obtuse angle. What has to be true?
Uh, don't they both have to equal up 180?
They add to 180.
180.
So I can write the following. 60 plus 5x plus 5y equals 180. Geometry is all about being able to set up an equation and solve it. That's
Okay.
what virtually all geometry problems are about once you get beyond proofs. Once you get into real geometry, proofs are not really real geometry, in my opinion. They're a different subject matter. But when you get into real geometry, it's all about translating the picture into an equation. This one says that the acute angle plus the obtuse angle is equal to 180. Now,
So, okay.
we want to solve for x and y. Well, my eraser isn't working here at the moment. What else do we know? Because we have three parallel lines. We have that one, we have that one, and we have that one. And we have these two that are both parallel. Now, something's not right here.
Okay.
And I'll tell you what it is. What's wrong with this picture? That's an acute angle. That's an acute angle. They got to be equal to one another. They're not.
Okay.
What does this say?
5x plus 4y.
I don't know what that means. What is that in reference to?
So it's showing that the angle right next to the 555, that's what the angle is saying.
So that belongs there?
Yes.
Okay.
No, right to the right,
Equation.
to the right of it.
Give me an equation that you can write based on that.
Oh, wait, hold on. That must be...
There's still a problem with this picture. All these lines cannot be parallel, because if they were, these two angles would be equal. 55 and 60 would be equal. They wouldn't, one wouldn't be 55 and the other 60. Not if everything's parallel.
I think I might have
You
written it.
draw it wrong, because this.
Oh, I did. Yeah, my other one says... Yeah, it says it's 60, 60, and the other one should be 5y on top too. So I just wrote the equation twice.
Like that?
Yes.
Okay. So, assuming that is that, which makes sense because it's the obtuse angle, that's also the obtuse angle. So, we absolutely know that those two angles are both 5x plus 5y. They can't be different.
Correct.
In other words, in this picture, all acute angles are 60. All obtuse angles are 120.
Okay.
Okay? So, to solve for x and y, I write two different equations. I write 5x plus 5y plus 60 equals 180. Right?
Yes.
That's for that set right there. You cannot solve for x and y on this picture. They could be, there's an infinite number of solutions. You can solve for x in terms of y, but from that, it makes me think that there is a unique solution for x and y, which means there's something wrong with this picture. Because this picture does not let me solve for x and y. Notice that this picture could be that. And everything would be exactly the same as you see in the picture, only that angle would be different.
Yeah, that makes sense.
So the picture doesn't make any sense, first of all.
Yeah, I think they're supposed to be. I drew them up vertical. They're supposed to be at an angle like that.
Well, that's not the issue. The issue is that everything that's labeled here does not let you solve for x or y. It lets you solve for x in terms of y, but it does not let you solve for a number.
Okay, so then that makes
I believe that you've made a mistake in writing this picture. Obviously, that isn't equal to that. So that's
I think I wrote it down from the board. Okay, so we can just. I think one of my last questions. If we can skip that one. I think I wrote it down wrong.
Okay.
I am able to like verbally tell you what it is.
Okay, hold on a second. Let me get my thing out so that I can write it. Okay, what do you got?
So it's two parallel lines up and down. And then you're going to have two horizontal lines across those two that are parallel as well. And then on the top left, it's going to be 1, 2, 3, 4 from that little box. Like right where you're writing, it's going to be 1, 2, 3, 4.
1, 2, 3, 4, like that?
No, so the 3 and 4 is going to be on the bottom of the 1 and 2.
Like that?
Yeah, perfect. And then on the other side, on the right there, it's going to be 5, 6, and then 8, 7. From right to left, 8, 7. Wrong. Yeah. So
first of all, everything goes left to right, not right to left.
Okay, and then it's going to be 13, 14, 15, 16 on the bottom. And then it's going to be 10, 11, 12. 9, 10, 11, 12.
Okay.
And then it's going to say measurement of angle 14 plus the measurement of angle 10 equals 180.
Notice that in this picture, all of the lines are parallel to one another.
Correct, yes.
That means that there are only two angles.
Okay.
Angle 1 and there's angle 2.
So then it wants me to figure out the angles for 16 and 3.
Okay. First of all, do we know what 1 is?
So it's going to be 14 plus, so wouldn't it be 90?
Okay. First of all, let's talk about this picture. I'm going to redraw this picture. To give some angular dimension to it, like that.
Yeah, okay, perfect.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Perfect.
Now the reason I did that is because I now have a bunch of acute angles and obtuse angles.
Okay.
Okay? Since all of the lines are parallel, all my acute angles are equal to one another. All my obtuse angles are equal to one another. So I want you to tell me what's equal to angle 1. All of them.
90.
Look for all the acute angles in this picture.
Okay. Okay, so isn't it
Deal with 1, 2, 3, and 4 first of all.
Okay, so yeah, isn't 2 obtuse?
Yes.
And then 1 it looks like it'd be a
Yeah,
cute.
I'm going to call 1 acute and 2 obtuse.
Okay.
So now find the other angles that are acute.
4,
What else?
8,
What else?
5, I would say.
Notice, hold on 1 second. 1 and 4 are also vertical. Whenever you have this situation, 1 is equal to 2. And 3 is equal to 4. That's what the definition of vertical angles is. Understand?
Understand? Yep.
Okay. So 1's definitely equal to 4 because they're vertical. And 4 is equal to 8 because they're corresponding.
Okay.
In other words, there's 2 rules you have to use here. One is my simple one. All acute angles are equal, all obtuse angles are equal. And an acute angle and an obtuse angle add to 180.
Okay.
With me?
Yes.
This is the picture you're going to be looking at 95% of the time. They almost never give you a picture like this, where you cannot tell whether it's an acute or an obtuse angle.
Okay.
All the pictures they give you are going to be like that, where it's really easy to tell if you have an acute angle or an obtuse angle. Just make sure all your acute angles are equal, all your obtuse angles are equal. And an acute angle and an obtuse angle add to 180. That's really the only thing you need to know about parallel lines.
Okay.
However, there is one situation where that isn't all you need to know. And that's when you can't tell whether it's acute or obtuse, like in this picture right here. I really can't tell by looking at it what's acute and what's obtuse. They all look to be approximately 90 degrees.
Correct.
Okay? So when it's like this, which you almost never get, but when they teach you geometry, they have to teach it to you by saying that 3 and 14 are alternate interior angles. Here, let's talk about the definition of all this stuff, because you need it. Unfortunately, this will handle 99% of the problems you get.
Okay.
But every now and then, they're going to give you one that looks like this. Okay, so let's talk about this. Alternate interior angles are equal. Tell me which 2 angles are alternate interior. Alternate means they're on opposite sides of the transversal.
Isn't it 1 and 4?
No. And interior means they are between the 2 parallel lines. Which 2 angles are on opposite sides of the transversal? There's your transversal. And inside the parallel lines. That's what alternate interior means.
1 and
1 is outside the parallel lines.
Oh, okay. Isn't it 3 and 6?
Yeah, those are alternate interior angles. The theorem says those are equal.
Okay. And then wouldn't 4 and 5 be equal?
Yeah, 4 and 5 are also alternate interior. Those are equal. There's also alternate exterior.
Which would be 1 and 8. 1 and 8 and 2 and 7.
1 and 8. In other words, there are alternate sides of the transversal, and they are outside the parallel lines, hence the exterior. You with me?
I am.
Corresponding. Tell me some corresponding angles.
Wouldn't it
are
be
also equal.
um
1, 1,
and
and 5.
1 and 5 and 2 and 6.
Correct? What else?
5 and 7, 6 and 8.
Nope. 5 and 7 are adjacent. Adjacent angles are always supplementary. They always add to 180. But how about 3 and 7?
Oh yeah, and then 4 and 8. Okay.
Yeah.
How
How about 2 and 6? Okay, so we got all the corresponding angles. Okay, those are always equal. And the last thing they really talk about in geometry is the adjacent angle. They're always supplementary, meaning they add to 180. Every adjacent angle up here adds to 180. 1 and 2, 1 and 3, 2 and 4, 3 and 5. Do you see where 3 and 5 are supplementary? They're not equal, they're supplementary.
Okay, yeah.
In other words, in this picture, you either have equal or supplementary. That's it.
Okay.
And this is in the hard picture, where they make it close to 90. If you're dealing with this, oh, hold on a second. Sorry. In other words, if you're dealing with the more traditional situation where they put an angle at it, they make the transversal at an angle, well, now it's really easy. You don't have to remember any of those things I just taught you. You don't have to remember alternate interior. You don't have to remember alternate exterior. You just need to look and see if it's acute or obtuse.
Okay.
So what is angle 1 equal to? All of them.
Angle 1 is equal to angle 5.
Okay. What else?
Also equal to 8.
Okay. What else?
And also equal to 4.
You got it. What's angle 2 equal to?
Angle 2 is equal to 3, 6, and 7.
Yeah, so all you're doing is searching out the acute angles, right? In other words,
Yes.
This one's obtuse, this one's acute. Any angle in this picture that is acute is equal to angle 2.
Okay.
So that's the easy way to do it. And that's the way that's going to work for you 99% of the time. The problem is when they give you a picture that's close to 90 degrees. Now I don't know which is acute and which is obtuse. So I have to remember these other definitions. Alternate exterior. A is equal to B, right? They're alternate exterior.
Correct.
C is equal to D. What is Z equal to in my picture on the right?
Z is equal to D.
Yes, corresponding. They're corresponding angles. So when we have a picture like this, we have to use those definitions, the detailed ones. But the thing is you don't ever get pictures like this. They may give you one on a test. But if you're taking the SAT for college prep, never going to look like this. Always going to look like this. Only they'll throw in another line to confuse you, like that.
Okay.
Okay? So you always want to be able to pull the picture out of 2 parallel lines and 1 transversal, even if they give you a couple of transversals here. All right.
I think.
What else? You good to go for tonight?
I think I am.
Okay, good.
Perfect. I appreciate it. Thank you.
You're welcome. Talk to you next time.
Sounds good. Thank you. Bye.